Greetings, welcome to another video from iCampSA. So we're doing the 2020 paper, November. So here we've got a 20 kg block. Okay, we've got a 20 kg block resting on a rough horizontal surface. Okay, these are the things to note, that this is a rough horizontal surface. Okay, and then it's connected to blocks P and Q by a light inextensible string moving over a frictionless pulley. So blocks P and Q are glued together and have a combined mass of M. Okay, as we can see from this diagram. So now they're saying a force of 35 newtons is now applied to the 20 kg block at an angle of 40 degrees with a horizontal, okay, as shown. So now they're saying the 20 kg block experiences a frictional force of magnitude 5 newtons. This is our frictional force as it moves to the right at a constant speed. So you can see that constant speed is written in capital letters as well as the direction, which is to the right. Okay, so that means it's moving this direction. Okay, so now first thing, they're asking us to define the term normal force. So let's write it down. This is 2.1. So what is normal force? So normal force, we are talking about a force here that is applied or that is exerted by the surface, okay, on an object. So we've got this this block here, and then we've got a surface. Then that means we've got a force here that is being applied by the surface on this block, and that force we call it normal force. And this force is always going to be perpendicular to the surface. Okay, so this is what we have for normal force. So we've got a perpendicular force that is exerted by the surface on an object. That object is the one that is in contact with the surface. So in this case, we're going to have this object here having a normal force. Now these objects here, because they are not in contact with the surface, they are not going to have a normal force. Okay, that's it. So the only block that's going to have a normal force is this one, which is going to have a force that is going upwards. Okay, so then 2.2 is saying draw a labeled free body diagram of the 20 kg block. Okay, so now 20 kg, we've already identified one force. We've got this second force here they've already given us, right? So if you look at the marks, we've got 5 marks. So if we've got 5 marks, that means we are looking for 5 forces. So we've got 1, we've got 2, then we're going to have 3 here. This 3 is coming from where? This is coming from our tension. And then they also stated that we do have what? We do have a frictional force. So that means it's going to be the 4th. And then lastly, you're going to have your weight here. Okay, this is it. So that means then you just come here and then you just have your dot. Okay, first thing, you've got your normal force. This is normal force. And then we've got this force that is applied. So we can say F applied, maybe F applied or FA, whichever. Okay, and then you're gonna have your what? You're gonna have your FG here, and then you have your T. Now what you need to note then is your frictional force. Okay, frictional force will always oppose the motion of the box. So if you can check here, we've got the box that is moving to the right, right? If the box is moving to the right, so that means the right is this side, then your frictional force is going to go in the opposite direction, which is the left. Okay, so that means here you're going to have what? You're going to have your frictional force, which is can be your FK or just small letter F. Okay, then that's it for your free body diagram. Okay, so for frictional force, always note that it's going to oppose the direction of the movement. Okay, so in this case, we're going to the right, and then the frictional force is going to go to the left. And then the next question here, they're asking us calculate the combined mass. Okay, M of the two blocks here, this P and Q. So they want that. So that means, what are we going to do here? We are going to use Newton's law. Okay, point 3. What does Newton's law say? We have F net equals to MA. That is 1 mark for you. That means you know what you need to do. Okay, so what we can do here, we already know that we have this free body here for block 20 kg, and then for this one here, we're gonna have, if we can do the free body here, we're gonna have a force that goes up, which is your T, and then we're gonna have what? We're gonna have your weight, which is your Fg. That is gonna be the free body diagram of P and Q combined. Okay, that is in one. So then what we're gonna do is we're gonna go and take block 20 kg. We're gonna do we're gonna apply Newton's law on this block so that we find out what is the tension force. Okay, how do we then go about this? So looking at this free body diagram here, we are saying to the right, we can say to the right as positive and then to the left as negative. We're gonna have to choose direction, and then we can say up as positive or down as positive, whichever. Okay, so in this case here, let's say we've got this. So if T is going to be positive, which is going to be T, then plus your Fk is going to be minus Fk, then plus your minus F applied. Okay, and then all equals to your M is 20. But now what you also need to note is that they told you that this thing here is moving at a constant velocity or constant speed. What does that mean? So constant speed, when they say constant speed, it means your acceleration is 0. So that means it's not accelerating, it's not changing. Okay, your acceleration, the speed is not changing. So if the speed is not changing, that means you're not going to have any acceleration. Okay, why is that? Let's just quick recap. So your acceleration, we know that it's going to be Vf minus Vi all over your Tf minus Ti. This is your time. Okay, this is your velocity. And then what's going to happen is if these two are not changing, so that means your Vf and your V initial are going to be the same. So if it's 5, you're just going to say 5 minus 5, and then you're going to have your Tf minus Ti here. So this here is going to be 0 over your change in time. Let's just say change in time. So that means this thing is going to be 0. Okay, that's why we say when the velocity or the speed is constant, the acceleration is going to be 0. So we can carry on now, and then we say our T here, we don't know what is our T, then plus minus what is our Fk. They said is 5, so that means we have a 5 here, and then plus, and then here for your F applied, you can see that the F applied is at an angle. So this means what we need to do is we need to find the X component. So we need to use the X component in this case, right? So we're gonna have to use the Fx, right, which is your F applied X, which is gonna be your F applied cos theta. Okay, this is going to give you your X component. Okay, so if we can just go back a bit so that we have this, we can say T plus minus Fk, then plus your minus Fa, but your X. Okay, all equals to your 20 and times 0. We can have something like so. So that when we carry on, we have a T plus minus 5. This is going to be a 5, then plus minus, this is F, your F applied here, you were given as 35. So that means you're going to say 35. So I'm now substituting into this here. This is where I'm substituting. Then cos, your theta is going to be the angle in between, which is your 40. And then equals to 0. Okay, so that means here, once you are sitting here, you can easily just manipulate this or just punch your calculator, and then you're going to get what T is. So I get T as 31.81. Let's just say, okay, this is tension. We are yet to find out what is our mass here. Okay, so that means now that we are done with the 20 kg block, we now need to move to this thing here, which is our P and Q. So for P and Q, what we do here is we're gonna do the same thing. We're gonna say F net again equals to MA. Okay, but now in this case, this M is this one here, which we don't know. And then again, the A is going to be 0 even in this case. Okay, it's going to be 0. I'm sure now you're asking yourself how we are going to then calculate our M if we have that. So if you can see here, we've got your FG and then we've got your T. Your FG we know is equals to mg. Okay, this is your mass times the gravitational acceleration. So if then we're saying we are choosing down as positive and then up as negative. As negative because this thing, that means it's moving downwards. It's gonna move downwards. Okay, because we said here this block is moving to the right, so that means it's just gonna follow a path like so. So we're just gonna use down as positive. So if we are using down as positive, we are going to have Fg minus T then being equals to MA. Then you can say mg minus T equals to MA again. Okay, this is what you have. So now once you are here, it's a matter of just substituting. So what we can say here, your mg, m we don't know, 9.8 is our our g, then minus T is what we calculated already, 31.8, and then equals to 0, because here you're going to substitute your A. So let's say just AM times 0. Okay, so you're gonna have your M times 9.8 equals to 31.8. So you can just divide both sides by your 9.8. Divide by 9.8 both sides. This will then go away. So then our M, what do we get? So get 3.25 kgs. This is what you have. Okay, this is just free 5 marks for you. Okay, now let's look at this next question and see. So they're saying here, at a certain stage of motion, block Q breaks off and falls down. So one of these breaks off and falls down, which is your Q here. So now we say we don't have Q. Now when we don't have Q, how will each of the following be affected when this happens? Then they're asking us here the tension in the string. Then they're asking you to choose increase, decrease, or remain the same. Then they're asking us again about the velocity of your 20 kg block. Then they're asking you to explain. So now let's go to the next page and see. So for 2.4.1, we're talking about tension here. So if then we decrease the weight, what's going to happen to tension? So we're reducing this weight here. Okay, so think of it in terms of a string, right? When you reduce this weight here, when you remove it, so that means you're going to reduce the force. Okay, and then in turn, if you reduce the force, if you reduce this part here, then this thing also is going to be reduced. Okay, just think of it like that. That's the simplest way you can look at it. So here we're going to take decrease. Okay, because you've got less force now. Let me just write this. Okay, you've got less force. 4.2. Then they're asking us here about the velocity of your 20 kg block. What's going to happen to the velocity then, now that we have reduced the weight? Are we still going to have a constant velocity? Is it gonna decrease? Is it gonna decrease? Or is it gonna increase? Which is which? Okay, so in this case, what's gonna happen, logically speaking, because look at this. You have, let's say, you had more force. This here tells you how much force there is. So it's more like take maybe a stone, right? If you look at this in terms of a stone that is pulling this, but if you reduce the stone, what's gonna happen? This thing is gonna slow down because you've reduced the force that is pulling this thing. Okay, because here you've got the force. This thing here is resulting in a force that's going to pull this whole 20 kg. Okay, and then when it pulls it, and then it's going to accelerate. But now if you reduce the force that you are using to pull this thing here, that means you're going to reduce the velocity. Okay, so that's what you can say here. So what you're going to experience here is your velocity is going to decrease. Okay, velocity will decrease. Now when you explain, you're going to explain in terms of your forces. Maybe you can use, because we've already decreased the tension force. So if we decrease the tension force, we decrease the net force. So here you can say your net force has decreased. Net force decreased because of the tension that we decreased. Okay, and then you can just say, you can maybe add something like when your net force is directly proportional to your acceleration. Your acceleration is directly proportional to your net force. Okay, so that's how you look at this. You try to use real world examples when it allows, so that it makes sense to you. Okay, and then this thing becomes easy. All right, that's it for this question. Let's meet on another question.